morning, students. Good morning, students. Today we discuss about area related circles final exam point of view models. Let us first orally I'll explain the formulas what we'll discuss. First, area of circle is pi r square. Circumference of circle, sometimes they may give perimeter of circle also, that is 2 pi r, where r is radius. If diameter is given, radius is half of diameter we take, and then after area of sector, that is theta by 360 into pi r square, 360 into pi r square. Length of arc means only this arc, that is theta by 360 2 pi r. And please apply, when major segment is there, don't apply that formula. First find area of minor segment, subtract from area of circle, that is best way. And next, area of segment means this part is called as segment, that shaded part. Area of segment formula, theta by 360 pi r square into minus r square sin theta by 2 cos theta. I mean this formula only expanded, r square is factorized over here. So pi theta by 360 minus sin theta by 2 cos theta by 2 r square, where theta is acute. This is applicable when theta is acute. Acute means, you know well, less than 90. Of course we get less than 90 only. If at all, if it is obtuse like 150 like that, first find a minor segment, then after subtract from circle. Enough. So theta pi r square theta theta by 360 pi r square minus r square sin theta by 2, we can, if we factorize r square, this form will come. This is formula to find area of segment when theta is acute, I mean up to 90. If it is more than 90, first to find minor segment value, or else from 360 when it is reflex angle, you find minor segment area, subtract from area of circle. Now it is given AB is the chord of the circle with center or radius 4 centimeters, and AB is the length of the arc 4 centimeter. Divide the circle into two segments. It is this is a minor segment. This shaded part is minor segment. Except this part, the remaining part itself is major segment. I mean major segment. This blue part is major. If you observe here, 1 minute. If you observe, this red part itself is a minor segment, except that from here to the rest part, total blue part is belongs to major segment. So we need to find minor segment area. How to find? So area here, if we observe, radius is given 4 centimeters. If diameter is given, half of diameter, you know. Length of chord is given 4 centimeters. Of course, here both are same to 4 only. And in triangle AOB, OA, OB, AB are equal. According to problem, AB also 4 centimeter. That is why automatically which type of triangle it is? Equilateral triangle. So AOB is 60 degrees, because we know in an equal triangle each angle measures 60 degrees. As AO in OAB triangle, according to given question, radii equal to length of chord. So OAB become equal triangle. So AOB is 60 degrees. Angle at the center of circle by this arc is 60 degrees. Now area of minor segment according to formula. Actually theta by 360 pi r square minus r square sin theta by 2 cos theta by 2. When r square is factorized, we have pi theta by 360 minus sin theta by 2 cos theta by 2 r square. R square is factorized. Substitute theta value as 60 and r value as 4. Then pi into 60 by 360 minus sin 60 by 2 cos 60 by 2 within the bracket 4 square. Here we can do cancellation. 61 the 66 the 360. Then after again here also 2 1s the 230s the. Again here also 2 1s the 230s the. So after simplification we have here 2 1s the 230s the. So after simplification we have here sin 30 cos 30. Okay, so pi by 6 minus sin 30 degrees cos 30 degrees into 4 square is 16. We know from the table, trigonometric ratios table, sin 30 is 1 by 2, cos 30 is root 3 by 2. So 16 of pi by 6 minus root 3 by 4 centimeter square. If they mention For suppose sometime root 3 value is given, we will substitute. It is not given. In area related circles, need not worry. In heights and distance or application trigonometry, root 3 will substitute either 1.73, 1.732. Root 2 will substitute 1.414, but here not required unless until they gave. So it is simplified and we have answer 16 pi. If you multiply by 16 both the values, 16 pi by 6 minus 16 into root 3 by 4. After doing cancellation, 4 1s are 4 4s are. Again here 2 3s are 2 8s are. So after simplification we have 8 pi by 3 minus 4 root 3 centimeter square is the area of minor segment. If they ask major segment, simple children, first find area of minor segment, subtract from area of circle. Enough. This is the way. And next go with next model, students. Here also it is mentioned the length of chord is given 12 centimeters and the angle is given 120 centimeters. The center angle is 120 degrees, center angle theta. Find the area of minor segment cut off by PQ. Here we know radius, here we know, and this method I don't suggest this method. First we'll do this method only, students. Area of minor segment is r square sin square pi theta by 360 minus sin theta by 2 cos theta by 2. Sin theta by 2, it is by 2 and cos theta by 2. Same method we discussed the previous problem. That method only easy. Never go with this method, students. So sin 120 is given pi into 120 by 360 minus 120 by, don't do this method, students. This method is lengthiest method. You do this method. I mean, this is correct only. Continuation. Here it is given theta value. This is not required actually, students. Radius we need to find. To find radius, we used this theorem. Here radius is not given actually. We applied here. We know it is a perpendicular bisector and it bisects this angle also 60 degrees. So we know opposite side is given. Hypotenuse we required, sin 60 we used. Sin 60 equals to get radius PD by OP. PD we know half of PQ because in class 9 used, if you draw any line segment from center to the chord, it is a perpendicular bisector, it will become 6 as it is 12 centimeter is given. So after that apply sin 60, we have sin 60 equals to 6 by r. Sin 60 value from trigonometric table root 3 by 2, do cross multiplication. So we have r equals to 6 into 2 by root 3, 12 by root 3. Do rationalizing denominator. Root 3 is the rationalizing factor. We have 12 root 3 by 3. 3 1s are, 3 4s are, 4 root 3 centimeters is the radius. Here radius of this sector, the segment. This segment, first we'll need to find radius by using trigonometric functions way. We have alter method also, but this is easiest method. 4 root 3 centimeters is radius. Now substitute in this formula. Pi theta, just now we used pi theta by 360 minus sin theta by 2 cos theta by 2 r square. Then theta value 120 degrees, it is given. Sin 120 by cos, sin 120 by 2 cos 120 by 2, and radius is 4 root 3 square, and after simplification we have pi by 3 minus sin 60 cos 60 was 48 square. This continuation over here. This steps continuation here, students. This is final answer. Remember this continuation answer it is. This continuation of this step. 48 into pi by 3 sin 60 value we know. Sin 60 is root 3 by 2, 1, and cos 60 is 1 by 2. And if we substitute, we get 48 into pi by 3 minus root 3 by 4 centimeter square. This is area of minor segment. After multiplying each and every term, and here 12 is LCM. So we get 4 pi minus 3 root 3 by 12. 12 1s are, 12 4s are. This is the final answer. Area of minor segment. So area of minor segment is, area of minor segment cut off by chord PQ is 4 of 4 pi 3 root 3, 4 pi minus 3 root 3 centimeter square. If they give root 3 value, substitute. Let us go with next problem. This is similar model to previous problem, but previous problem we found angle by using equal triangle property. Here we found radius by using trigonometry ratios. This, but same formula we use, the same simplification. Unless until they gave root 3 value, need not substitute, need not worry. Next question. A chord of circle radius 14 centimeters make right triangle at the center. Find the areas of minor and major segment of the circle. Already I said, first we'll find minor segment area. Subtract from area of circle, you get minor segment, I mean major segment 2. Here according to figure is my students, Radius of the circle is given. Angle, it is right angle means 90 degrees. Same formula is applicable. Pi theta by 360 minus sin theta by 2 cos theta of r square, where r is 14. Substitute all the values in the formula. Pi into 90 by 360 minus sin theta by 2 cos theta by 2 ante sorry children, I mean sin 90 by 2 cos 90 by 2 and substitute, simplify. We get 14 square, as we know, 196 of 22 by 7. Here it is mentioned. Actually, when it is possible to cancel, we can, or else write in pi terms only, unless until they gave. So here it is given that but when we are finding major segment area, pi value substituting is must, no doubt. When they said find only minor segment, you write in pi terms, no issue. But when they said find both the segments, we need to substitute to get the other values. And moreover, if it is possible cancellation, we have to. So if we do 28 after simplification, we have 28 ones are 28 sevens are, you can do cancellation in your own way, no issue. Again here also 2 ones are 2 98s are. So after cancellation is your wish, students, no need to depend on teacher only. You can do your own cancellation. It is 98, keep in mind. So next step, you can observe that value whatever given. So here 22 sevens are 154 minus 98, 56 centimeters. That is this minor segment. This is minor segment, students. This is ACB part, down one. Red one is minor segment. That yellow part is the rest part from here to here, total major segment. Okay, student, this we have to find. Yellow part, only yellow part of the circle. Yellow part of the circle. So area of major segment equals to area of circle minus. If we subtract this area from circle, we get major segment only. So 616 is area of circle. Area of circle minus, already we got 56. That is why see, major means big only na. That is why it is 560. It is 56. We can understand major big, now it is. So similarly we do next one, students. Here it is given, find the area of circle whose circumference is given. Here radius is not given. We need to find its area of circle. Simple, students. Circumference area we know 2 pi r equate to this one 22 44. First substitute, whenever we are finding pi value, we should substitute either 22 by 7 or 3.14, depends on problem. If they give to 3.14, 3.4 take. 2 into 2 pi r is circumference formula, as we know. By using circumference, we have to find its area, means radius. Without radius we can't do. So to find radius, we equate to 2 pi r. Substitute pi value 22 by 7, 2 into 22 by 7 into r equal to 44. Transpose another side. This is in division, it changes into multiplication. The 2 and 22 are multiplication, you can change into division. 22 ones are 22 twos are 2 ones are 2 ones are. Cancellation your way, children. 2 ones are 2 ones are. Then we got radius 7 centimeters. Area of circle is pi r square. Substitute, we get 154 centimeter square. And the next problem is given, circumference of circle exceeds means increased. Diameter by 16.8 centimeter. Find the circumference of circle. Radius of circle, let us take r. Circumference equal to diameter plus 16.8 means 2r plus 16.8. So circumference of circle formula 2 pi r equal to 2r plus 16.8. Send 2r this side. 2 pi r minus 2r equal to 16.8. 2r is common, pi minus 1. After simplification and substituting 22 by 7 and taking factorization, 2r into 22 by 7 minus 1 equals to 16.8, and we know 7 is LCM. 22 minus 7 by 7 into 2r, that is nothing but 2 by 7r. 22 minus 7 so equals to 168. We wrote 16.8 decimal form to fraction form, that is 168 by 10. And then after simplification, we have 2 into 15. 22 minus 7, 15 by 7r. So if we transpose on the side of equality, it will become division. So after reciprocal, after simplification, we got 392 by 100, that is 3.92 centimeters. Circumference we know. If we substitute and factorize, we get circumference of circle 2r plus 16.8 according to question. We r else 2 pi r also you can take, that is no issue. If you take 2 pi r also, same value you get. If you write 2r plus 16.8 also, same way. So 2 into 3.92 plus 16.8. 7.84 plus 16.8, that is 24.64 centimeters. Circumference also a length. Area is centimeter square, circumference as it is length in centimeters. Let us go with next slide. A steel wire bent in the form of square encloses area 121 centimeter square. If the same wire bent in the form of circle, find the area of circle. I mean nothing but reshaping, remodeling into another shape, from square shape to circle shape. First, as we know, that is area of square is nothing but 121 square centimeter according to that question. Area is given. If circumference is given 4a, I mean if they give length of wire 4a, but here they clearly mention area, it is enclosures. If we equate to r square, I mean we know area of circle is, area of square is side square. Side equal to root over area, because square can change to root. Root over 121, 11 centimeters. Perimeter of square is 4 into side, 44 centimeters. According to given question, circumference of circle and circumference of wire, circumference square should be same, because we are reshaping square to circle. That is why both circumference should be same. Area might be different, but circumference are same. So according to formula, 2 pi r equal to 44. Again, we just now we did this model. Transpose, substitute pi value as 22/7. Transpose, it become reciprocal and do cancellation. Just before we did, r is 7 centimeters. Area of circle is pi r square. Formula we know, just now I said 22/7 into 7 square, that is 7 cancel. So we got, if this 7 cancellation is your wish, we got the value 154. Then we need to find a ratio between, so we have this one. So area, we need to find area of circle according to formula 154 centimeter square. This is the way to do. Again, one more question is given. Circumference of two circle are in the ratio of 2:3. Find the ratio of their areas. We know circumference formula 2 pi r. So according to formula, let us take one circumference of one circle is 2 pi into capital R, not to get confused. One is capital R, one is small r, we took radius. So 2 pi capital R by 2 pi small r equal to 2:3. As 2 pi cancel, 2 pi same cancel, r by r equal 2:3, means ratio between their areas is 2:3. So as we know, area of circle is pi r square by pi r square, capital R square, small r square, capital R by small r whole square, nothing but 2/3 whole square, that is 4:9. This is the way to do, how to find the ratio. This is another model, students. Next, let us go with next model. Here it is given, find the radius of circle whose circumference equal to sum of the circumference of two circles. Radius for 15 centimeters and 8 centimeters. Very simple, students. Let us take circumference of one of the circle as 2 pi r. I mean required circle 2 pi r. Let us take radius of two circle r1 r2, that is 15 and 18. If you substitute in the according to formula, r1 we took 15, r2 we took 18. According to problem, circumference of required circle equals to sum of the circumference of first circle plus circumference of second circle. 2 pi r equal 2 pi r1 plus 2 pi r2. 2 pi factorized. Here 2 pi is factorized, students. 2 pi of, if you factorize 2 pi of r1 plus r2, as we know, 2 pi get cancelled. If we transpose another side of equality, it will become division. Anyhow, we can cancel each other. So here 2 pi cancel. After cancellation, we got r equal to r1 plus r2, as radius of new circle is sum of 15 and 18, 33 centimeters. This is one of the application on area radius circle. Let us go with next model. Let us go with next model. Again, here radii of two circles are given, 19 and 9. This is similar model to NCERT. Find the radius of circle which is containing circumference to sum of circumference of two circles. Same model, but here it is radii given. We'll substitute 56 pi. So radii, if we take and we get the value 28, and if they ask areas also, we can find area of the required circle also, pi into capital R. Here r1 r2 are radii of given two circles, same model we did it is, but apart from that we found even area also here, pi into capital R square, area of new circle. Let us go with the next model. This is another model, students. If we see a sector of circle whose radius and angle of contains angle, means angle of sector theta, find the area of sector. We know area of sector formula, two ways are there. One is when angle of sector and radius are given, that is theta by 360 pi r square. When length of arc and radius is given, lr by 2. If length of arc, radius is given, lr by 2. Both are area of sector only, but depends on situation we used. Now area of sector is theta, means here according to formula, according to problem, 135 angle, radius is 8, substitute the values, pi value in terms of pi, because they did not mention, we wrote. If they give pi value, we'll write. If they mention, we'll write, or else this is also correct. After doing cancellation, we have, after doing cancellation we have here, so do cancellation in case of in table, after simplification we have 3 by 8 pi r square, and so r is here, r is here 8 centimeters, students. So after simplification we have, so cancellation is your wish, students. 45 table we can do, 45 8s, 45 3s, the cancellation is your wish. Do with 5 table, and at any cost same answer you get. 8 1s, here we can do cancellation, 8 8s, but pi is same, 8 pi will come here. So 8 pi into 3, it is 24 pi centimeter square. Let us go with next problem. Like this, many models are there, students. Here the area of square inscribed in a circle, square is inscribed. Find the ratio of their areas of circle as well as square. If you observe, students, here ABC, it is a square, it is mentioned. ABC is which type of triangle? Is a right triangle. AC is the diagonal, where diagonal is nothing but diameter of the circle. So let us take radius of the circle as r, and circle square, diagonal of AC square is diameter of the circle, that is equals to root 2a. We have a formula for square diagonal. If side is a square or radius, side is a diagonal will be root 2a. Very earlier class we will learn. So diagonal of square is nothing but diameter of the circle, root 2a into 2r. Then after a equal to 2r by root 2, simplification. Area of circle is pi r square, area of square is a square. Let us take ratio of the areas, pi r square by a square, which is 22r square. 22r square by pi value 22 by 7, we substituted 22 by 7 r square by 2r by root 2 whole square. Simplification after 22 r square by 7 into 4 r square by 2. If we take reciprocal, we get, under simplification here we can do cancellation, students. After total cancellation, we have 2 1s are 2 2s are 2 1s are 2 11s are r square cancel variable, and 11 by 7. So ratio of their areas is 11 by 7, or else in terms of pi is to 2. Anything is same. But if they are, my suggestion, both you write. No sir, no wrong at all, but simplification method. So let us go with the next model. It is given the area of enclosed between the concentric circle 770 centimeter square. The radius of outer circle is given 21. Find the radius of inner circle. Simple, students. Outer circle, let us say, already given 21, and total this area of path, circular path, this red area of circular path equals to pi into capital R square minus pi into small r square. Area of outer circle minus area of inner circle is area of circle path. So 7, that is 770 according to question. 22 by 7 into 21 square minus 22 by 7 small r square, radius of small r circle, 770. Substitute. Then we can do cancellation here. 7 1s, if we do cancellation, we get 7 5s are 35. So 7 6 also possible. 7 6 that 42, 7 3s are 21. 63, 22 is the 1386 minus 22 by r square equal to 770. So after simplification, we get 1336 minus transpose this side plus 22 by 7 r square equal 1386 plus 7 7. By transposing LHS sometimes to RHS, RHS to LHS sometimes, we get 22 r square equal to 616. After transposing, we get reciprocal, and then after 22 ones 28s, we get 216. So we have here 28 r square equal to 827, 196, 14 square. Square and root cancels. This square, if base are equal, we can cancel squares. So r is 14. Radius of the inner circle, what we need to find according to problem, that is 14 centimeters. If they ask diameter, 2 into radius 28 centimeter. 2 into 14, 28 centimeter. We'll go with the next slide with the next model. In an archery target, three regions formed concentric circles as shown in the figure. The diameters of concentric circle is 1:2:3. Find the ratio of their areas of three regions. Let us take when ratio is given 2x, x, 2x, 3x. Instead of that x, here take k. And after some comparing the area similarly, and after that you know these areas how to compare and simplify. What are the positive same terms are there? Cancel. After simplification, k square also possible to cancel. If all these three what are common will cancel it. So we have 4 also get cancelled. 1:3:5 is the ratio of their areas. Let us go with the next slide. A square of diagonal 8 centimeters inscribed in a circle. Find the area of region outside the circle and inside the square. Nothing but shaded region. So let us take radius of the circle as r, and the length of diagonal square is 8 centimeters given. So just before we discussed diagonal equals to diameter of the circle, which is nothing but a root 2 equal to 8 diagonal, a equal to 4 root 2 centimeters. Diagonal of the square is nothing but diameter of the circle. So diameter of circle 8 means radius will be 4, diameter by 2. Area of circle is pi into r square, 16 pi centimeter square. And the area of square formula a square, which is 4 root 2 square. 4 root 2 square means 4 square into root 2 square, which is 632. So here we have 32. So area of circle is pi r square. We have 16 pi centimeter square. As we know, r is 4. So after area of square we have, so the area of shaded region equal to area of circle. Just now we have done minus area of square, which is 16 pi minus 32 centimeter square. So required area of shaded region is 16 pi minus 32 whole square, so 32 centimeter square as it is area. Next, another problem. This is another problem, students. Don't get any confused. Here we have done in one slide 2 problems to reduce the time. And the terms in terms of find in terms of pi the length of arc. Just now I said length of arc formula theta by 360 into 2 pi r, where a angle of sector is given 30 degrees and radius is given 4 centimeters. Radius and angle of sector theta is angle of center standard by arc, subtended by arc is nothing but angle of sector. Don't get any confused. Length of arc formula theta by 360 2 pi r or 2 pi r into theta by 360. Substitute 31 the 32 the 30 cancellation is your way, students. 31 the 32 the again here we can do cancellation. 4 2 the 4 3 the cancellation is your wish. 2/3 pi centimeters, as it is length is in centimeters or units or meters. Here centimeters given, so centimeters we need to find in terms of pi. We got it. Let's go with the next models. Find the angle subtended at the center of circle, radius 5 centimeters, 5 pi by 3 centimeters it is given. So according to formula, length of arc is given and radius is given. So we'll substitute, I'll find angle. Reverse model. 2 pi r into theta by 360, that is 5 pi by 3 given already. Whatever possible cancel it, pi get cancelled, and 3 ones are 3 120s are do cancellation in your way, no wrong at all. After simplifying we get 1 by 6 of 5 theta by 362 equals to 1 by 6. So 6 ones direct cancellation is your wish. Here they did another way. No rule cancellation, no rule to follow. Which method we are explaining? So theta is 360 by 6, which is 60 degrees. Angle of sector means when length of arc is given or area sector is given, we can find, and radius is given. Any two values is given, third value we can find by using this model. Let us go with next problem. Length of arc subtended by angle theta. By find arc length. Length of arc is 15 centimeters. Angle of sector is given, and find center of at the and find the terms of pi, radius of circle. Radius of circle we need to find in terms of pi. So angle of sector is given. Length of arc formula theta by 362 pi r. Substitute the values we know, except r, rest we know. Substitute, and 48 ones are 48 8s are, once again I'm saying cancellation is your wish. After writing this 8, it is 8, students. 45 ones are 45 8s are, so we have 8 over here. 2 pi r into 1 by 8. If we do simplification, r equals to transpose another side of equality. Numerator will become denominator, denominator will become numerator. Then we get r equal to 15 into 8 by 2. 2 pi to 1s 2 4 the 15 4 the 60 and cancellation your way student 60 by pi centimeters it is mentioned. Find radius in terms of pi. Let us go with the next model. Let us discuss another model. The angle of in a circle radius is given, radius of circle and arc subtended arc at 72 degrees at center. Find length of arc and area of sector. Already we discussed length of arc formula when angle of sector and radius is given theta by 360 into 2 pi r or 2 pi r into theta by 360 depends on, no issue. And area of sector is when angle of sector and radius is given theta by 360 pi r square or pi r square into theta by 360. Substitute, simplify, we get the answer length of arc 44 centimeters, and after that theta by 360 pi r square or this formula reversely also 770 centimeter square. After finding length of arc here nothing but L, we can use area of sector another formula also, that is area of sector equal to when length of arc and radius we know LR by 2. Of course same formula, same answer you get. Length of arc how much we got here 44, length of arc is 44 into radius already how much given 35 by 2. So same way we can do students, this is also one of the formula to find 2 1s are 2 22s are 2 22s are 44, 22 35 is how much 770, means what students, here we got area 770, here also 770, we can use both the ways. I mean area of sector when length of arc we know LR by 2, when angle of sector and radius we know theta by 360 pi r square. Let us go with the next slide. So when it is given the perimeter of certain sector of circle radius 5.6 centimeters is, I mean perimeter of sector is given. Perimeter of sector formula L plus 2R. Remember perimeter of sector equal to L plus 2R. So R else perimeter minus 2R also they gave. Anyway correct only. Find the area of sector. First we need to know L value, length of arc if you know we can find, and then or else we can find radius and we can do anyway correct only. LR by 2 is correct way. So area of sector formula here used there. So anyway it is correct only. But what I suggest here, perimeter of certain circle is given, radius is given L plus 2R. L plus 2R equals to 27.2. So here if we simplify and radius is given L equals L plus length of arc, L is given 27.2, perimeter is given, radius is given 5.6, so 2 into 5.6 equals to 27.2. This method also applicable, whatever method I am teaching also applicable. 2 into 5.6 how much, L equals to, if we transpose on the side of equality it will become minus 27.2 minus 2 into 5.6 how much, to 6 12 2, so 11.2 we get 11.2. If we subtract 11.2 from 27.2 we get the value, that is the length of arc. So 27.2 minus 11.2 is 16, it is the length of arc. So L value already I said, when length of arc and radius we know area of sector formula, A stands for area of sector, equals to LR by 2. What is the length of arc we got 16, radius how much given, so area of sector equals to length of arc is 16, radius is given 5.6. So if you multiply 8 with 5.6 we get the area of sector. So how to find? See how 5.6 is 5.6 students. So by 2, 2 ones are 2 8s are. So if you multiply 8 into 5.6 if you do, you get the area of sector as 4.8 centimeters. Let us go with the next slide. The minute clock, already I said minute clock means find the area, describe the minute clock phase by 7 a.m. to 7:05 a.m. means 5 minutes. Total time rotation for 5 minutes. Angle of sector for 5 minutes equal to central angle 5 by 60 into 360 because in 1 hour minutes clock makes 360 degrees. We need for 5 minutes. So 5 by 60 into 360. After doing simplification we get 30 degrees. I mean that clock, here you take clock, and that clock example you take students to move 7.5 to 7 to 7.5. It is 7. Let us take it is 7. Here at 7 is there. To move 7 to 7.5, here one for angle sector, it is 30 degrees. Here angle is 30 degrees. So theta is 30 degrees. And length of minute sand is nothing but radius. Radius is R is 21 centimeters. Angle, central angle is nothing but angle of sector 30 degrees. Substitute area of sector form in area of sector formula. Theta by 360 pi r square or pi r square into theta by 360, both are same. So 22 by 7 into root 2 whole square into 360, 30 degrees by 360. 31 the 32 the cancellation is your way, students. No need to follow my method only. Here we get root 2 square, root 21 whole square is square and root cancel. So we have 21. After simplification, we got 22 by 7 into 22 1 into 12. Then 7 1 the 7 3 the. And after simplification, we have it is 3. 11 by 22, that is after simplification we got 11 by 22, which is 5.5 centimeter square. Let us go with next and same next problem. Same way, minute sand is given 10 centimeters long radius. Find the area subtended or faced by minute sand from 8 a.m. to 8:25, means 25 minutes. Central angle again, before we did 5 by 60 into 360, but here 25 by 60 into 360, because in 1 minute, 1 hour 25, 1 hour 60 minutes, total total angle, complete angle 360 degrees. So for 25 minutes, 25 by 25 by 60 into 360, which is 150 degrees centigrade. Same way we'll substitute, we'll simplify. We got 130.95 centimeter square before problem, and these two problems are similar models, only angle of sector is different. Next problem, length of minutes and is given 14 centimeter. Find the area by minute and in 5 minutes. Same, it is direct problem. 14 for 5 minutes, again 5 by 60 into pi r square they give, or else find angle and do, anyway it is correct. Length of arc will substitute it, means simplify. 51.33 centimeter square according to area swept by minute sand. That's it. This is the way to do. Next, let's go with next problem. Again, it is area of circle, length of arc, and area of sector is given. Length of arc formula L equals to theta by 360 pi r square, or length of arc formula L equals to theta by 360 2 pi r, 2 pi r into theta by 360. Area of circle pi r square, circumference 2 pi r. Substitute, simplify, we get the values. That's it. This is the way to complete, students. Here if you observe, area of sector formula pi r square into theta by 360, substitute the value, simplify, we get here area of sector 34.54. area of length of arc L equals to, this is nothing but L also, students. L equals to 11.51 centimeters. Area of sector pi r square, substitute and simplify, 113.04 centimeter square, and circumference 2 pi r, that is 37.68 centimeter square. Now let us go with the next slide. Let us go with the next slide, students. So it is given rectangular PC is 20 meters long and breadth is 15 centimeters. Form a 4 corners quadrants. Quadrant means 1 by 4 pi r square, that you keep in mind. And then after 3 point, that radius is 3.5 centimeters, means this corners here 3.5, here 3.5, here 3.5, here 3.5, here 3.5, here 3.5. I mean length by 2 3.5, breadth by 2 3.5, it reduced. Let it be. We need to subtract area of rectangle minus 4 into area of quadrant. Area of 4 into area of quadrant means 4 cancel it, it forms 1 square. I'm sorry, 1 circle. Really sorry, children. If you add 4 quadrants, it will become 1 square, 1 circle. If we subtract from rectangle, if we subtract area of circle enough, area of remaining part equals to area of rectangle minus area of circle. Nothing but 2 pi r square. Pi r square is area of circle, 22 by 7 into, it is given 3.5. For our convenience, we wrote as 7 by 2 to do cancellation. So do cancellation, to 1s to 11s, 1 7 will cancel. So we have 77 by 2, that is 38.5. Here already area of rectangle formula length into breadth 300 minus 38.5, which is 261.5 centimeter square. Whenever shaded regions are given, to find remaining part, we'll subtract shaded region from bigger area. This process is approaching method is easier to do. Let us go with the next slide. A square water tank has its sides equal to 40 meters. There are 4 semicircular grassy plots all around it, and find the cost of turfing the plot at a rupees 1 rupee 25 paise per square centimeter square. Pi considered as 3.14. It is given pi value. Please note down this value also, students, not to get confused. Side of the square is 40 centimeters, 40 meters. Radius is according to formula. Diameter is 40 according to question. Radius will become 20. So area of 4 semicircle equal to 4 into 1 by 2 pi r square, because semicircle formula, area of semicircle formula half into area of circle, that is half pi r square. Then after we got the value whatever substituting after, but here pi value is given 3.4. Keep in mind 2 into 3.14 into 22 by 3.14 into 20 into 20. As we know, 3.14 we substituted, 2 ones are 2 2s are here only cancellation. You are with students any way you can do, but final answer should be same. So to we got final answer 800 into 3.14, which is 2512 meter square. Turfing the plot, 1 rupee 25 paise, multiply you get. And in this is different model, students. According to this question, area of quadrant is given and a square is given and the side of square is given. We need to find shaded region. Actually, according to concept, shaded region equal to area of quadrant minus area of square. Area of square we can find side into side, but area of quadrant to find, we need to find the radius of the quadrant. To find radius of the quadrant is nothing but diagonal of the square, which is root 2 times of side to 21 root 2 centimeters. So radius of the quadrant is root 2 times of diagonal of square, which is given. By applying Pythagoras theorem we get. Apply Pythagoras theorem and do, or else directly remember diagonal of square equal to, when side of the square is given, root 2 times of square, side of the square. So 21 root 2, substitute area of quadrant minus area of square of 1 by 4 quadrant formula, 1 by 4th part of circle, which is nothing but quadrant, 1 by 4 pi r square minus side square. Substitute, simplify, we get the answer for 441 into 8 by 14. Cancellation is your way, students. Keep in mind this, and we get 252 centimeter square. Cancellation is your wish. Next, let us go with the next slide, students. In the next slide, it is mentioned that find the same, this is same model we have done already, so you can approach the same model. So substitute, simplify, area of the remaining part equals to area of square rectangle. We have done that model. Again, 4 cows are tethered or tighted, 4 corners of the year 1 cow, year 1 cow, year 1 cow, year 1 cow. 4 cows are tightened with the length of threads are given 25 meters, and because square plot is given 50, in that half is radius of the radius of the each quadrant, nothing but length of the thread tied. We need to find, so that they just cannot reach one another, what will be the area of left ungrazed. This part, the shaded part is ungrazed area. So to find that simple way, side of the square is 50 meters according to given question, it is given, and radius of each quadrant according to given question exactly half of side 25 meters. Area of quadrant we know 4 into area of quadrant is 1 by 4 pi r square, but 4 quadrants are there. 4 into 1 by 4 pi r square, which is one circle, pi r square. We'll substitute, we'll find out. We got 22 by 7, 625. After simplification, we have 1969.29 centimeters, 29 meters square. This is 1964.29 meters square is the area of place they can graze. Area of ungrazed is area of square minus area of grazed area. Area of square formula, side into side, here we found already 2500 or 2500 meter square. Subtract from this, we get 535.7 meter square, 0.71 meter square, means that much area is ungrazed. Let us go with next slide. So here a cow is tied with a rope of 14 meters at the corner. Here there's a length of this one is 14 meters, and it is 14, students, it is not 16, 14. So here we need to find area which cow can graze. Simple area of sector formula, radius 14, angle of sector it is 90, because they mention it is square shape, rectangle shape. In a rectangle, one of the corner 90 degrees. So area of sector is 90 degrees. Substitute and simplify 154 meter square area it can grace. So in this process we can simplify. Once again I'm saying apply area of sector formula. This forms a sector and the angle at the each angle of rectangle is 90 degrees, and according to formula length of thread is nothing but 14 meters. Don't think about a side, only we need to think about this length of thread area, that is 14 meters. Only this sector only we need. So substitute, simplify, we get the answer. Next, same model students, we need to find diagonal. Diagonal of square is nothing but root 2 times side, and substitute, simplify. Same model we did. Area of quadrant minus area of square. Area of quadrant we got by substituting 1 by 4 pi r square, 628 centimeter square we got. Area of square, side square 20 square 400. Final answer 228 centimeter square. We have done same model. Let us here again, here it is given that four equal circles, each radius touches each other, so the area is this one, this shaded area. Let us take side of each side of square is 2 centimeters. Radius of each quadrant become A because half of side of square, and we know area of shaded is equal to area of square minus area of quadrant. 4 quadrant, nothing but 4 into 1 by 4 pi r square, 22 by A square we have, and area of square is 4a square. 4a square minus 22 by 7a square. Take LCM. 28 minus 22 by 7a square. 6 by 7a square. Hence it is proved. Simple way, students. Area of cylinder is equal to area of square minus 4 into area of quadrant, nothing but area of circle. Let us go with next slide. When the next slide is given, again one trapezium is given, and then the corners 18 centimeters, each having 18 centimeters radius. I mean, sorry, children. Area each corner having 7 centimeter. This is 7. This is 7. This is 7. This is 7. This is, I mean, each sector is 7 centimeters. 4 sectors. Nothing but one circle. Nothing but one circle simply. And the area of trapezium minus area of circle, because keep in mind students, what is the sum of four angles in a trapezium? It is a quadrilateral. 360 means 360 by 360 pi r square, that is nothing but pi r square circle. So area of trapezium formula half into sum of parallel sides into height is nothing but this perpendicular parallel distance 14 10 centimeters, half into AB 18, CD 32 14, and do simplification we got 350, and area of circle is pi r square 154 centimeter square pi r square. So area of cylinder is equals to 350 minus 154 196 centimeter square. Once again I am saying whenever four corners occupied any quadrilateral, four quadrant means that is sum of four angles in a sum of four corner angles of a quadrilateral is 360. So it forms a, if you attach all those sectors, these four sectors in any quadrilateral 1 2 3 4, if we attach these all four, it will become circle with radius of given. Here radius is given 7 centimeters. So area of trapezium formula will substitute, will find area of trapezium. Pi r square will substitute area of circle. Subtract from area of trapezium, from minus area of trapezium minus area of circle, we get shaded region. Let us go with the next slide. In the next slide it is given here, let us just keep little careful student, this is very important problem. In the given figure we need to find area of first part, area of second part is area of quadrant minus triangle. After that from semicircle we'll find, we don't know radius diameter of the semicircle. By using Pythagoras theorem we can find, we know hypotenuse equal, if it is the right triangle, isosceles triangle, hypotenuse equal to 40, I mean 14 a root 2, nothing but 14 root 2 from Pythagoras theorem. We substitute area of semicircle, will find area of triangle, will find, subtract from area marked 1 equals to quadrant minus area of marked 2, so we get 56 centimeter square, and area of semicircle we find half pi r square, and simplify we get finally area of part 1, part 2, part 3. So semicircle area minus area of part 2, sorry, part 1. Part 1, how do you get? Quadrant minus this. Part 2 students, part 2 is 56, and we get the area. Now let us go with next slide. Here area of circle, here little careful students, these parts are overlapping. We should not take these two parts two times. In square already it is included. That is why little careful while doing this problem. According to formula, side 28, radius half of that, 14 centimeters, area of skeleton equals to 3 by 4th part of circle. Here 1 by 4, 1 quadrant, here 1 by quadrant is removed. So after doing simplification, we get a value. Again, we need to find out. This is the processor, little careful. Let us go with next slide. Okay, student, these are the main models covered. Main models covered in the area of circles. So please go with this. Thank you, students. If you have any doubt, you can WhatsApp to my number 739 639 4288. These are the different models from area related circles. I will do all the chapters within 2 days like that. Please keep on watching. You can ask me doubts through this WhatsApp number. Thank you.